All right, so we are told that we've got a wooden block with a density of 0.597 grams per centimeter cubed, and we place it in ocean water, and we're told the density of the ocean water, what fraction of the block will be submerged. Well, the first thing we want to do is we want to figure out the density of the object relative to the density of water, of the water that we're dealing with, right? And so in this case, I think the best way to do it is to really use a shortcut or a rule of thumb. So I'll show you the shortcut first, because I really think that's the right way to do a problem like this on the MCAT. You don't have that much time. You don't have enough time to really go through the math, but then I'll also show you the math just in case. So the shortcut is that all of these fractions are in the same relative order of magnitude, right? That is to say they're all less than 1 and greater than 0.1, right? And so from that, we can understand that if we were to divide this number by this number, we want to divide them in such a way that we're going to get a number that's between 0.1 and 1. So let me show you what I mean by that. So 0.597, right, divided by 1025, of course, is going to give us a number that's much smaller than 1, or much smaller than 0.1 also, right? But if we were to do 597 divided by 1025, right? In that case, what we would end up with is we would end up with a number that is, this is a fraction that's less than 1, but not substantially less than 1, right? And if we were really to simplify this to 600 divided by 1,000, you'd understand even further what I'm talking about here, right? 600 divided by 1,000, if we were to cancel out the zeros, we end up with 6 out of 10, 6 over 10, which is 0.6, right? So we understand that we're dealing with 0.6, right? The relative density of this object is 0.6, right? So this is really a shortcut that I strongly recommend you do, rather than try and convert the math, right? And so if 0.6 is our relative density, what fraction of the block or the object will be submerged? And so we know that it is 0.6, right? The rest of the object is going to float. So since we wanted to round, right, we rounded a little bit. So the correct answer here is going to be A. And we remember, we can know that because if the density were higher, if the density of the block were higher, let's say the density of the block were, or the relative density, let's say were 0.9, right? That's very close to 1. That means almost the entire block would be submerged. And so that means the object would be more dense. And so based on that, you can kind of intuitively figure out whether we're talking with this fraction about whether that fraction is submerged or floating, right? Because of course, if we were asked a different question of what fraction of the block would would float above water, then the correct answer would be this one, about 0.4, right? 1 minus 0.6 would be about 0.4. So we want to make sure we understand what they're asking. Now, let me go ahead and show you very quickly how we might want to convert this unit so that we can turn this from grams per centimeter cubed into kilograms per meter cubed. And again, I would not recommend you actually do this on the test. You wouldn't really need to, and it would take you far too long. And this is really a much easier problem than that. But let's go ahead and see what that would look like. So we'll convert this first of all to scientific notation. 5.97 times 10 to the minus 1 grams per centimeter cubed, right? So if we were to convert grams to kilograms, we would multiply this times 1 times 10 to the minus 3, right? Because there are 10 to the minus 3 kilograms in a gram. And then what we would do is we would do times 1 times 10 to the 2, because that's how many centimeters are in a meter, right? There are 100 centimeters in a meter. And then that times 3, because of course we're dealing with cubed, right? So 2 times 3. And so that comes out to 5.97 times 10 to the minus 1 times 10 to the minus 3 times 10 to the 6th. And since these are all tens, we can kind of just add up the exponents. So minus 1, minus 3, that's minus 4, plus 6, that's the total exponent is going to be, so 5.97 times 10 squared, right? And that's going to be equal to, well, 10 squared is like that, so 597. So if we wanted to convert units, we would end up with 597 kilograms per meter cubed, right? But again, that's really not the fastest way to do this. I do not recommend you do it that way. But if you had to, that's how you would do it. And so I think it's a fairly straightforward problem. You really just have to understand what relative density is and how to figure that out. And again, as I said before, there's an easy way to do it and there's a hard way. And so that's how you want to solve a problem like this.